the bottom of page 2, we're going to talk about subsets and set equality. Let's start with subsets. So in this first bullet point, it says if each element of a set A is also an element of a set B, we say that A is a subset of B. Okay, so this whole idea of a subset is pretty important in this section. Okay, so make sure you understand it. Let me give you an example of a subset. So let's say we have set A, say we have 2, 6, and 10 in set A, and then let's look at set B. Let's say it's 2, 4, 6, 8, 10, and 12. Okay, so when you look at this, okay, A is a subset of B because every number that is in A is also in B. Okay, so if you look at 2, 2 is in A, 2 is also in B. And then you have 6, 6 is in A, it's also in B. And then finally 10, 10 is in A, it is also in B. Okay, so every object that is in A is also in B. So A is a subset of B. On the flip side, okay, B is not a subset of A, okay, because if you look in this statement, okay, there is at least one element of B that is not in A, okay? So like 4, okay, the number 4. 4 is in B, but it is not in A, okay? So you can't say, it is not true that every number that is in B is also in A, okay? So B is not a subset of A, okay? There is notation that we use for subsets. Okay, so let's go down here. Okay, so it says if, right here, if A is a subset of B, this is what we're going to write. We're going to write the set A, and here's the notation you use for subset. Okay, it's the strange looking little symbol. Okay, that means subset. So A is a subset of B. Okay, if A is not a subset of B, you're just basically going to write it again. So write A is a subset of, and then scratch out the subset notation. Okay, so A is not a subset of B. Okay, all right. Again, at the bottom of this page, you have two statements in blue. Okay, blue statements are important. Okay, every set A is a subset of itself. Okay, here's why. So again, let's stay simple. Let's pick the set A equals 1, 2, 3. Okay, so when you're thinking of subsets, you're usually thinking of two sets. We're just basically looking at the same set here. Okay, so every element of A is also in A. Okay, if 1 is in A, it's also in A. If 2 is in A, it's also in A. If 3 is in A, it's also in A. So A is a subset of itself. Okay, kind of a interesting idea. Okay, but it's true. It's true by definition. Okay, every set is a subset of itself. Okay, here's another important one. Okay, the empty set is a subset of every set. Okay, again, if I had the set A is 1, 2, 3, by definition, the empty set is a subset of A. Okay, remember what subset means. A set is a subset of another one if every element in the first set is an element of the second set. So when you look at this statement, the empty set is a subset of A, every element in the empty set is technically in the set A because the empty set doesn't have any objects, okay? So it's kind of like a technicality, okay, because the empty set doesn't have any objects. So every object in it is technically in another set, okay? So just kind of keep that in mind that that's a rule. The empty set is a subset of every set, okay? Last thing on here, the bottom of the page, if set A and set B have exactly the same elements, then the two sets are said to be equal, okay? So if you're dealing with two sets, they're considered to be equal sets if basically they have the exact same objects, okay? All right, let's go to the top of page 3. We're going to give this whole idea of subset a try, okay? So in example 2, we are looking at the set S equals, it's got 4 objects, A, B, C, and D, okay? In part A, you are asked to list the elements of the set, and then in part B, you are asked to list the subsets of S, okay? So the idea of element and subset, those ideas are different, okay? So let's talk about that, okay? In part A, you are asked to list just the elements. The elements that, that's a fancy name for the objects inside, okay? This set has 4 objects, okay? A, B, C, and D, okay? You don't use braces here, okay? Because it's not asking you for a set. It's just asking you to list the objects inside, okay? So basically, you may encounter some complicated sets as we go through this section. So basically what you have to do, if you're trying to figure out what your objects in your set are, what you should do is like take off, if you get your set, okay, scratch out the braces on the end, okay, and what's left, those are the objects inside the set, okay, if that makes sense. All right, so moving on to the second part, okay, now we're going to list the subsets, okay, so remember what a subset is. Every a set is a subset of another set if every object in the first set is in the second set, okay? So this is how we're going to do this, okay? So let's start off small, okay? Since it's a subset, it has to be a set. So every subset you form is going to be in braces, okay? So the first subset I'm going to write down is just the set A, okay? It is a set. Every object in this set, lowercase a, it is also in the original set, capital S, okay? So this small set is a subset of capital S, okay? So any object that just has one element is going to be a subset of capital S, okay? So the set of just B, that is also a subset. The set of just C, also a subset. The set of just D, also a subset, okay? So then you can bump it up. Say you have 2 elements, okay? So A and B, okay, that's also a subset of capital S, okay? Every object in this set is also in S, okay? A is an object in S, B is an object in S, okay? So you might be wondering, do I need to write BA, okay? And the answer is no, because AB and BA are the same set, okay? So you don't write it twice because this is not a different subset, okay? Remember when you're listing objects, the order does not matter, okay? No matter if you have AB or BA, it's still the same set. So I'm going to erase this, okay? So we need to pair them up in twos, okay? So how can we do this? Well, we paired A with B. Now let's pair A with C and then A with D. Okay, so A's been paired up with everybody. Now let's pair B up with everybody. B's been paired up with A. So now we need to pair B with C and then B with D. Okay, so now B's been paired with everybody. Okay, and then let's pair C with everybody. C has been paired with A right here. And then C has been paired with B right here. So now we need to pair C with D. Okay, so that's another subset. Okay. And I think D has been paired with everybody. We have AD, BD, and CD. Okay. So those are all the different combinations of 2 objects in the set. Okay. So each one of these guys is a subset. All right. Now we need to pair them up in threes. Okay. So we've got A, B, and C can be combined. A, B, and D. Okay, those guys can be a combination. How else can we do this? We can do B, C, and D. Okay, that's another way to get 3 of them. All right, so you're probably thinking that we're done. Okay, again, so far we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 subsets of S. Oh, you know what? I forgot one. When we were doing the threes, we forgot to do A, C, and D. That's another one, okay? So yeah, it gets a little bit tricky. You've got to make sure you have all your combinations, okay? So far we have 14 subsets, okay? So you're probably thinking, okay, we're done, okay? But remember, we learned a couple of things on the previous page. All right, so remember, the empty set is a subset of every set. Okay, so we need to go back and we need to put the empty set. That's another subset. Okay, and we learned one more thing right here, these two statements in blue. Every set is a subset of itself. Okay, so we also need to write this set down. Okay, so I think we end up with a total of 16 subsets. That's quite a bit. Okay, but any of these sets that you pick, okay, so like, pick a random set like this one, okay, every object that is in this set, every letter that's in this set is also in the set S. So this is a complete list of subsets of this set, capital S, okay? Again, keep in mind the difference between an element and a subset. The element, okay, these are just the objects inside, okay? Subset, you have to, use the set notation here,